Going to be talking about compass and true bearings. You guys are going to learn how to apply compass bearings and true bearings to application problems. Now, this probably would have been better right after we did laws of sines and cosines and we looked at some of those application problems, but it still falls under the geometry and trigonometry unit as a whole, and so we're going to talk about those today. So, your compass bearings. I don't know when you first learned these, maybe second grade, third grade, okay, where you learned about north, east, south, and west. Yes? North is at the top, south is at the bottom, east was to your right, and west was to your left. Okay? What you guys see here are compass points, different types of directions that can be given to you in an application problem dealing with, let's say, a ship is traveling north 40 degrees east. Well, that basically means from the north direction turned to the north direction turned to the east direction 40 degrees. That is basically the path that that particular boat is traveling on. Okay? Or it could say a plane heads west 20 degrees south. Well, that means that if the plane were to travel in the west direction, it turns towards the south direction 20 degrees, and that is the path, the direction in which that plane is heading. Okay? So whatever compass point comes first, that's where you're starting from, and then the end compass point is basically the direction that you're turning towards, and the angle in between is the angle in which the angle that is created. Okay? And of course, there's northwest, southeast, southwest, northeast, etc., etc. That just means that it's split straight even, 45 and 45. Okay? Because each of the compass points, they intersect northeast, southwest at what kind of angle? A 90-degree angle. Yes. Okay? So you can use that to help you determine maybe the angle inside the triangle or whatever the particular application is asking you for. Also, north to south, how many degrees is that? 180 degrees. Okay, so don't forget those as well. Okay, all the way, like this, how many degrees is that? 270. Okay, what if you went all the way around, going from north all the way back to north? How many degrees is that? 360. Okay, and so don't forget about some of those basic concepts because you might have to use those depending on what the application problem asks you to do. Okay, and we are going to look at an application problem after we talk about true bearings. Question.
So for it to be 360 degrees, would it say north?
Oh, they'll never be a 360 degree one. But let's say you had north 270 degrees east. That means you're technically heading in this particular direction 270 degrees, and then technically that's the direction in which they're heading. But I've never seen anything like that. It's usually an acute angle in between your compass points, and so you'll know that you'll head in that particular direction somewhere in between 0 and 90. But the ones where I have seen where they say,
sorry about this, if you are.
But what I have seen being used with the larger angles, the more obtuse angles, is three-figure bearings. They're also known as true bearings. Okay? This one is used a lot more when it comes to navigation, direction, etc., etc. Okay? But true bearings or three-figure bearings give direction as angles are measured clockwise from the north direction. Clockwise from the north direction. Okay. So again, you're going, starting from the north direction, going clockwise, and it'll always be clockwise. And so this is what you may see. You may see 0, 35 degrees, 110 degrees, 270 degrees. So that means, again, from the north direction, going in the clockwise fashion, that is how you're creating those angles. Okay? No matter what, it's always clockwise, it's always from the north direction. If it's anything that's less than 100 degrees, there will be a 0 in front of it because because it is three-figure bearings, so you need a number in every single place. 110 degrees, again starting from the north direction, heading clockwise, 110, which is a little bit past 90 degrees. And then 270 degrees, again, you start at the north direction, and you travel 270 degrees, which would technically put you in the east direction. Yes?
So with negative angles, we just go counterclockwise?
Yes, but I've never seen a negative angle three-figure bearing. Okay?
Do they do like reference angles?
No. You don't have to worry about reference angles. Okay. So let's look at an example. Okay? So we're going to look at this example. A ship is sailing north from a point A towards point D. Point C is 175 kilometers north of A. Point D is 60 kilometers north of C. There's an island at E. The bearing of E from A is 0, 55 degrees. The bearing of E from C is 134 degrees. This is shown in the following diagram, and as you can see, that diagram is blacked out. Why do you think I blacked out that diagram?
Because it's a secret. It's a surprise.
It's a surprise? Yes, and the surprise is on your desk. I want you to see if you can create the diagram. I want you guys right now to see if you can create this diagram based off the explanation in that top paragraph. Okay? Since a ship is sailing north from point A to point D, you need two things on your picture so far. You need point A and you need point D that's in the north direction from A. So north is straight above, and there's D. Just like in a compass, with your compass points, this technically would be north, this would be east, south, and then west. Then it says point C is 175 kilometers north of A. So from A, heading north, C is 175 kilometers north of A. And then D is 60 kilometers north of C. So that means DC, that segment is 60 degrees. There's an island at E. Island E does not represent east in our compass points. Okay, it literally is an island somewhere. And the next sentence tells you that the bearing of E from A is 0, 55 degrees, which means that from A, because it says from A, heading 0, 55 degrees, that means from the north direction, turning clockwise 55 degrees, you have island E. And then the bearing of E from C is 134 degrees. That means from C to get to E, you have a 134 degree bearing. 134 degrees is more than 90, but less than 180. So again, from the north direction heading clockwise, you have 134 degrees. And that's what your diagram should have looked like. So, that is your diagram. Are there any other questions? All right. So, with that being said, and I do need this space to make sure I answer the question, I'm going to go ahead and show it there. So, in that way, I can use this. Okay? Now, it's asking you to find the bearing of A from E. Those words are important. They do distinguish because you're going from E to A. And if you're looking for a bearing, remember, bearings always come from what direction? North heading clockwise. So that means from E and from E's north direction, because I can put a little compass north, east, southwest from any point that's on this graph or on this picture. So from E heading north to A, I am looking for this angle right here. Did everybody catch that? Because if I'm looking for a bearing has to come from a north direction from a point heading clockwise. So from E and E's north direction, I need to figure out what that bearing is, so that means going clockwise. I'm looking for that angle. Now, right now, I can already see that this angle is going to be bigger than what number? It's going to be bigger than 180, because it definitely is, I draw these out, it's definitely bigger than 90, definitely bigger than 180. I'm just trying to get to that point there, okay? So, I need to determine what that angle is, okay? And this goes back so, because again, this is from a compass setting. Let's take that idea that Christian had, okay? Which I think this is what you were saying, correct?
Yes.
Does everybody see that there? When I draw this dotted line right here, I'm technically going south of point E. And if I were to draw a line from A to that line that I just drew down, what did I create? A right triangle, okay? Every vertical and horizontal line forms a 90-degree angle. So those two blue lines that I just drew, they form a 90-degree angle. So do segments AD and that blue line that I just drew. So those two angles, 55 and then that angle that's not labeled, should add up to equal 90 degrees. So then what's this angle right in here?
35.
And then you subtract 90 and 35 from 180 to get this angle right in here. What's that?
55?
It's 55. And if you notice, that red angle 55 and then that printed angle 55, they are equal. And if you think about it, two north directions are parallel lines, and AE serves as a transversal. Alternate interior angles are congruent. So if this angle right here is 55, and I already know that this angle is how many degrees?
180.
180, I can find the bearing from of A from E by just adding 180 and 55.
235.
Yeah.
It's 235. Oops. 55. It's 230.
I should write this down.
So now that I have that bearing, let's find CE. CE is this segment right here. I'm looking for that segment, CE. Now this goes back to the first little bit of geometry and trig to find segment lengths of non-right triangles. What concept am I going to use? Law of cosines. There's only one problem. Law of sines. There's only one problem. What problem am I talking about?
That angle right there. The C.
I need some other angles.
You can do
That's for
180
sure.
minus that.
So, in order to do law of sines to find segment CE, I am going to use the fact that since this is a 180 degree angle, I can subtract 134 from 180 to get 46. This angle is 46 degrees. Now that 46 isn't going to help me because I'm looking for CE, which means that I'm going to actually need the angle CEA. I need this angle right here. But now that I know two angles out of the three in my triangle, I can add those and subtract them from 180 as well. So, I need to add 46 and 55 and subtract those from 180. When I do that, what do I get? 79. So this angle right here is 79 degrees. And now that I have an angle across from a given side and the angle across from the side I'm looking for, I can find CE, which is labeled X right now. So that's 79. Nope, that's not 79. That's 175 over the sine of 79 is equal to X, or CE, over the sine of 55. Go ahead and find CE. You cross multiply and divide, so then that's going to be CE is equal to 175 sine of 55 all over the sine of 79, which is what?
146.
146. 0.04, so three significant figures would be 146, and that is kilometers. Then part C is asking us to find DE. DE, which I'm going to draw in after I erase some of these other items. What can I use to find DE?
Law cosines.
Law of cosines, because I have two sides and an included angle. I have CD, which is 60. I have CE, which you guys just found, so please make sure you do not use the rounded answer to find DE. So go ahead and do that. Do not use the rounded answer for CE when you're doing this.
Yeah, with 3/6.
All right, yeah, so make sure that after you do all this, you take the square root, and DE is equal to 192.6, which rounds to be 193 kilometers. Be careful, make sure you post all your parentheses. Before we get to D, because D is talking about speed of how fast these boats are going and everything, I want to make sure that you guys are okay with the bearings. Okay? Alright, so let's finish off this problem real quick. It says when the ship reaches D, it changes directions and travels directly to the island at 50 kilometers per hour. So when that boat turns and it decides to go from D to E, it's traveling at 50 kilometers per hour. At the same time a ship changes direction, a boat starts traveling to the island from point B. This point B lies on AC between A and C and is the closest point to the island. The ship and the boat arrive at the island at the same time. We're trying to find the speed of the boat that is basically leaving from point B. Okay? And as you can see, this one says 5 marks. This was an IB problem that I basically kind of cut and pasted so I could try to fit all into one slide and big enough so that you guys can see. But this one is 5 marks. The other ones I think were between like 2 and 3 marks. This one was the biggest part of this long response problem. This is a long response problem. Okay? So on a clean page with some space for myself, when you are traveling a certain distance at a certain speed, isn't there a way that you can figure out how long it takes you to get somewhere? What's that formula? Say again? Rate time. There you go. Distance equals rate times your time. How far you've gone is equal to how fast you're going and how long it took you. Okay? Or how long it takes you. So then here, we already know how far the first ship traveled to go from D to E. And we also know how fast it was going. So we can figure out how long it took the boat to get, or the ship to get from D to E by plugging in what we know. We know, again, this is from D to E. This is that ship. It traveled 192.6 and some change kilometers. it was traveling 50 kilometers per hour. We just don't know how long it took. So to solve for t, what would we do?
Divide 50 by both sides.
Divide 50 by both sides. Now you still should have 192.6 in your calculator, so you can scroll up and then divide that number by 50 and get how long it took the ship to go from D to E. Can you do that right now?
Yeah.
Say again.
3.85.
3.85 and some change. Okay. So almost about 4 hours is how long it took that ship to travel from D to E. Now it says at the same time as the ship changes directions, a boat starts traveling to the island from point B. Is point B on this picture?
No.
Which means you're going to have to put it on this picture. We're going to put B where it says in the next sentence. It says this point B lies on AC. So B is somewhere in between A and C. Specifically, the closest point to the island. The shortest distance between 2 points is going to be that distance that is perpendicular. Okay? So, this distance that is perpendicular from E to B along AC, that is the shortest distance. That segment that creates a perpendicular with AC. If you try to put it anywhere else, it's always going to be longer. The shortest distance between a point and a line is the segment that's perpendicular to it. That's back from geometry. So, the ship and the boat arrive at the island at the same time. Find the speed of the boat. So, in order to find the speed of the boat, I need to figure out how far the boat, which is at B, is from E. And then on top of that, considering they got there at the same time, I'm going to probably need to use that as well. Okay? So, I need the distance. Let's find BE. Now, in your picture, you probably have some other items, right? You have 46 here, and you also know what CE is. What's CE? It was 146.02, right? What concept am I going to use to find BE? I can do SOHCAHTOA because I have a right triangle. 40 is my acute angle. I'm looking for BE. BE is my, sorry, that's 46, my bad. I have a 46-degree angle. BE is my opposite, adjacent, or hypotenuse. Opposite. So I'm just going to redraw this real quick, just in case you can't see it. So to find BE, this is my opposite side, what I'm looking for, and the 146 is what? So what trig ratio am I going to use? Sine. So the sine of my angle is equal to my opposite side over my hypotenuse. Again, do not use the rounded answer, use the non-rounded answer to find BE. Do that now. All right, so we're using our answer to CE, that non-rounded answer, and we're multiplying it by the sine of 46 to find BE. And our answer is what? 105 and some change, right? Okay, should be 105. Make sure you're using that 146 number. Are you in degree mode? Double check. Question.
Would you also be able to do the form where it's like PE over sine 46 equals 146 over sine?
You could use all. So now we have what we need to find the speed of the boat. So again, we're going to use the same formula here to help us figure out the speed of the boat. Because now we know how far apart B is from E. And since the boat and the ship got to the island at the same time, we know the time as well. Okay? We found the time right here. So we plug in what we know. That's 105 and some change is equal to R times 3.85. We can find how fast the boat was going by doing what?
Dividing both sides by 3.5,
Dividing both sides by 3.85. Again, I'm putting these dots because I don't want you to use the rounded answer. The more you round, the further off from the correct answer you're going to be. And a lot of you guys do have that feature of just pressing the up arrow to retrieve an answer, so use that feature. If you don't have that because you have an older calculator, that's why I also write out close to everything, so then that way you can just retype what you need, and then you can just use second negative to pull that answer down. So, what is 105 and the rest divided by that 3.85 number?
27.3 if you do 360.
Which would be 27.3, and what's the unit here? Per hour?
Yeah.
Oh my lord.
KPR. Wait, no. Where? Holy.
Yeah, Watch it. But that's how long or no, not hours. We're talking about speed, so sorry, kilometers per hour.
That's pretty slow.
It is kilometers per hour. We are talking about a boat compared to probably like a cruise ship. But that's how you apply bearings to an application type problem.